All right, so today we are looking at chapter 7.5, continuing to explore exponential functions, but mainly we're going to look at table of values and the first and second differences. Now on the first page, it sort of reviews first and second differences for linear functions and quadratic functions. We've done that a lot, and you've probably done that in grade 10 and even grade 9 for linear functions. But just for a recap, okay, I will post these as usual. But linear functions, such as the first one, all the first differences are the same. And exponential functions, such as the second example, all your second differences are the same. So then the question becomes, well, what happens in an exponential function? First, second differences, third, fourth, fifth, I don't know. Let's take a look. Well, I do know, but let's explore that. So on the back, we have the exponential function. This example, y equals 2 to the x plus 3. Okay, we'll talk about this 3 a little bit later in this lesson, but basically it's a vertical shift. So it takes your whole function and moves it up 3 units. But we'll talk about that later. Let's just look at this for example. Now we have a table of values. So we have x and y. And they give us 0, 1, 2, 3, 4, 5. And our values for y are 4, 5, 7, 11, 19, 35. And then if we analyze our first differences, so let's try this. 5 minus 4. Always the second one minus the previous one. That's 1. Okay, well 7 minus 5. That's 2. 11 minus 7. That's 4. Okay, 19 minus 11. That's 7. Nope, 8. And 35 minus 19 is 16. Now that's an interesting pattern. 2, 4, 8, 16. It looks like it's just powers of 2. And that's really interesting because our exponential is powers of 2. Even the 1 is a power of 2, right? 2 to the power of 0 would be 1. Okay, well that's kind of interesting for our first differences. What happens if we do it again and figure out our second differences? Second differences. Well, 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. We're coming up with the exact same pattern, right? Powers of 2. And you can do this again for third differences, right? 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. You're going to get the same pattern on first, second, third, eighth differences. You will get powers of 2, which is very interesting because the exponential function we analyzed is base of 2. Okay, and this we call, we can actually determine that base by taking what we call the common ratio. Take any number in either first or second differences, they're the same. Take any number and divide it by the previous number. Right? 8 divided by 4 is 2. 2 divided by 1 is 2. 4 divided by 2 is 2. And that common ratio tells you the base, right, of your exponential function. All right, well, we looked at 2 exponential functions. This is an increasing one. What about a decreasing one? Is it the same pattern? So the next example is a decreasing exponential function because the base in this case is 1/2. So you have y equals 1/2 to the power of x, and then we just throw in that plus 3 again. So I want you to try this yourself. They do have the table of values already there for you, so you don't need to substitute anything. All you need to do is find your first and second differences. And then see if the common ratio is the same as your base, which is 1/2. So does the common ratio equal 1/2? give you a hint? Yes, it does. But definitely go through this to prove to yourself that it works. That's what math is all about. Not taking someone's word for it, but proving to yourself that it works. And then I will post these so you can double check that. What I'd like to do now is to go back and talk about this. Now I said this is a vertical shift. So on the back of whatever page this is, it says summary. Down at the bottom, right, it tells you to sketch some functions. I want to do the first one together. And then you can try the second one. So we have y equals 3 to the power of x plus 1. And we have to sketch that. All right, so first, you need to figure out where your y-intercept is. Now, your y-intercept usually is always 1. Because if we don't have that number, something to the power of 0 is always 1. So when x equals 0, this first term is always 1. But now we have a second term. We're going to add 1. Right? 1 plus 1 is 2. So there's our y-intercept at the point 0 and 2. Now, we also know the base is greater than 1, so we know that it's an increasing function. Now, there's another term I want you to know. It's called asymptote. An asymptote is sort of a made-up line where we know the function will always get closer to, but never cross. Now, usually, up until now, we haven't had this 1 in here. And for increasing functions, they always came closer and closer and closer and closer to 0, but never crossed it. So our asymptote was always y equals 0. But in this case, it's not going to be y equals 0. It's going to be y equals 0 plus the whole function shifts up 1 unit. So at this point, I'll make it a dotted line because it's not an actual function here. It's an asymptote. At this point, y equals 1. We have an asymptote where the function always gets closer to, but never crosses. And then you go through the intercept and then just blow up. Okay, so in order to graph these exponential functions, in order to sketch them, I want you to be able to find out where the asymptote is. And just a hint, that's your asymptote, right? And then where your y-intercept is. And it's always the asymptote plus 1. Okay? We're not going to go over functions that are negative and go that way. But we do have decreasing functions. So the decreasing function in our example is 1/4 to the power of x minus 2. So 1/4 to x minus 2. So think about it. Where would your asymptote be? Okay, and where would your y-intercept be? Camera just went really fuzzy. There we go. Okay, so there's your asymptote, and then your intercept is always 1 more than that. Okay, and then you're just going to draw it as a decreasing function. So make sure you try that, and then you can check my answers. Alright, so that's it for this lesson. You can also make sure you try the examples on the back for homework. Okay, I will post my answers so that you can see, but definitely try them first before looking at my answers, right, to make sure you understand that. After this, we just have 2 more lessons, exponential growth and exponential decay. Okay, and those are great examples which lead into the next and last chapter, which is on finances. Okay, so probably the beginning of next week, I will post a Chapter 7 quiz. So you can even start working on your Chapter 7 assignment. Download that from the Google Classroom and just avoid any word problems, because the word problems will be a growth and decay, which we'll get to in our next lesson. All right, see you later.